spoofing the prompt origin URLs. So I'm based on Dubai, and I work at a company called Katim, where my core roles and responsibilities are to perform security research on secured mobile phones. Apart from that, I also look for mobile and API security. It's been a decade that I'm doing bug bounties on various platforms. And yeah, I'm quite passionate about exploring the world, and it's my second time in Prague, so I love to explore every new countries. Yeah, so we'll talk that why this topic matters. So nowadays, if you visit any e-commerce website, any social media website, first it will ask you to grant the current location permission. If you maybe visit Instagram, it might ask you to grant a camera permission or something like that. So permissions are quite common right now nowadays. Mobile and web views. So if we talk about web browsers, at least it shows the like URLs and parameters and something like that. But when it comes to web views and mobiles, it hardly shows the URL, and if sometimes in application it doesn't even shows the URL, it just shows the title. Pre-installed frames. So lots of companies allow third-party companies to do a marketing by loading their ads into the frames. And last, AI generated codes. So nowadays it is very common that every developer uses AI, and AI doesn't actually think about the privacy. It focuses on the performance. Obviously think about the privacy, but they doesn't dig deeper into the privacy. So the agenda would be how permission policy works, why different browsers or different engines has different implementations. I'll be showing the video that how we can actually spoof your permission origin in the permission prompts. And last we'll discuss that if this is a feature or it's a security bug. So what is permission policy? So if a developer wants to restrict certain browser APIs but wants to grant certain APIs, for example, there is an application requirement to give camera access but not a geolocation access. In that case, developers or application uses the browser permission. So in that, developers can enable and disable certain browser calls. And what is the core objective? Obviously, to limit application for certain APIs for the security, for the privacy reasons, and as well as the performance reasons. Yeah, so we'll dig more about the permission prompts and permission policies. So before 2015, there was no such thing in browsers called permission prompts and permission policies. So in 2015, browsers introduced what are the permission prompts, in which browser shows that from which origin application is trying to access certain permissions. So for example, camera, location or something like that. But there was no such way to restrict those APIs. It just shows the permission. But next in 2018, the permission policy got introduced, in which developer can actually enable and disable certain features. For example, just enabling a geolocation, not enabling mics or any other sensitive APIs. Yeah. So this is very basic, that how actually permission policies can be implemented within the applications. So the developer has to set a HTTP header in which they can declare the policies, and within the attribute they can also declare that which API should be accessed and which API should not, and from which origin the APIs should be allowed, and they can also block the origins as well within the header. And yeah, that similarly works at the enabling or disabling browser APIs and something like that. Now, this is very new thing which I have discovered while I was just playing with the APIs and everything. So Chrome has a robust support when we talk about this permission policy header, that you can enable and disable these features for any APIs. Similarly, Microsoft and Opera, their core engine is a Chromium based engine. So they have this feature where you can enable and disable all the APIs. But if we talk about Mozilla Firefox, Apple Safari, and iOS WebView, so they do not support entirely, or yes, they support for microphones, but if for other APIs they do not actually support. So you can come and just exploit it. If we talk about the WebView, yes, it supports, but usually developers misses the implementation, and many times Android WebViews are quite older versions. The developers doesn't bother about updating the current version. Who will attack and at what state? So as I have mentioned that lots of companies allow third-party application or websites to display their advertisement. So in that, it loads a sensitive data within the frame. Spyware vendors, if we talk about Pegasus or Hermit or something like that, their main focus is to steal sensitive information, track down a human activities, and just exploit it. And at what state? Obviously, a privacy. Ad companies can steal geolocation data, and probably according to that, they will target the user or something like that. Sensitive data exposure. Obviously, if spyware will abuse this bug, they can track down where you are moving, what you are speaking, and obviously, if you are sitting, they will just randomly click a photo. So, a basic attack overview. So, in general, if we want to spawn any of the browser API, we would require the JavaScript injection. We can say XSS or something like that. But in this, HTML injection is enough. With the HTML injection, it can be exploited. We will embed our malicious code within the hidden frame and hidden frames domain in such a way that it will not actually display to the victim that what type of data is being loaded within the frame. Permission hijacking. Once victim will trust on our website and allows the permission, it will hijack all the APIs, which are camera, microphone, and GPS APIs, geolocation APIs, and then from there we will steal the data, the location. We'll be taking photos. We'll be silently recording. So vulnerability identification. So it is very simple. Browse any website. Find for HTML injection. It can be XSS. XSS can also be exploited. But let's say it has a CSP policy, then in that particular scenario, you probably not be able to execute the JavaScript, or maybe you can bypass it. But there's gonna be huge hustle if any of the user input or user pass data is passing in any of the things which are like inner HTML, outer HTML, then in that particular case, we can also exploit this vulnerability. And why I am talking about this? So, let's say I have found XSS in Facebook, and if I am sending the link to any of you, like, hey, can you add me a friend request? Probably you will trust, Facebook, and Facebook will ask that Facebook wants to, access your camera. You'll think that, okay, fine, it's a social media website, and, probably this is the basic feature that we have to grant the permission. So that's why, I'm talking about the finding the HTML injection within the application. Yeah. So we'll be, as you can see, the trusted site. So within the trusted site, I have loaded a frame. For the frame, I have basically displayed the different frame tags in order to explain in the easier way. So I'll be loading a malicious. So I have hosted my malicious content on attacker.com, which is managed by me, managed by attacker. On that particular frames attribute, I'm asking for the geolocation, camera, and microphone, and I have set the opacity to 0. So in that case, in that particular scenario, it will not actually show that there is one frame being loaded. It will show a normal website that, okay, fine, this is the website. Once this will get loaded within the trusted websites page, it will ask for the permission. Since we have mentioned the attributes within the frame, and with the HTML injection, we have injected these particular frames within the trusted website. So now this code is this particular 3 frames are part of the trusted website. Trusted website whenever the trusted website gets loaded, browser will think that, okay, this is the part of the trusted website. Trusted website wants to access microphone, camera, and geolocation. And user would probably, grant access that, okay, this is the trusted website. This is the basic requirement in order to, use certain features or something like that. So it's something like that. So we have loaded hidden frame where which is attacker.com, where our exfiltration code is hosted. We have mentioned the permissions, that which API we want to invoke, and setting the opacity to 0. Whenever it will get loaded, it will show like this, that trusted website wants to allow access your camera, and so and so. And prompts. If you see any of the browser, the prompts will be the same. So this is like the Safari, Firefox, and this is like, if you can see the top on the maybe URL, it's an Instagram. So probably if I am sending a trusted website over the Instagram, so you'll probably trust that, okay, fine, this is the legit thing. Data exfiltration. So as soon as you will grant the permission, attacker which the attacker hosted their vulnerable code or the code on the attacker.com's website, it will, as soon as invoke that particular APIs and start exfiltering the data. So once you have given the permission, it will start tracking you down that, okay, fine, this person is here, and if you actually move, it will quite show that this person is moving until you close the browser or tab completely. It will continuously click a photo of the user. I was just sitting randomly and it started clicking photos of mine. Similar like that, it also performs a recording if you grant a microphone permissions. And so I was just I'm not a kind of person who goes to a conference and gives a talk, but this is something new for me. So I started digging more research that let's say if I want to present this, I have to be very clear that, from thinking about attacker perspective. And I was just reading some sort of things that, how many people usually clicks on allow without actually, going through the domain. And according to some research, to some university, I honestly, I don't remember, 70 to 80% people will click on allow without, thinking about that from which URL it is actually asking for the permissions. So, probably, yeah. Can you just go to the settings and slow down the video? Just go in. So this is the legitimate website where I have loaded my attacker another website where I have hosted the code, and it shows that legitimate website tries to access these APIs. So basically, it was a recording where it was continuously recording what I am speaking. And why defense fails? So, if you open this particular URL which has been sent by the attacker, and when it loads within the page, it will show the trusted websites. If we talk about mobile, so the URLs are quite small. So, or maybe it will only show the title of the particular website, that what type of which website is being loaded and which application is trying to access those permissions. And iOS and Android, if we talk about it, people usually do not focus on permission policies when it comes to loading data within the Android or iOS web use. So how it can be mitigated? As a web developer, if it's a sensitive application and it needs some restrictions, you can probably set permission policy headers, and if you want to allow certain websites to be accessed, you can define it within the attributes. If you talk about the mobile applications, it has an option on permission request and WKUID delegate. If you use it, you can set up the permission policies for the APIs over there. For the browsers, it should actually show that from which origin the data is being asked, or on which origin you actually it is sending the data on initial permission prompt only. And users, if you think that you might have shared some permissions on some website which are shady or something like that, probably you just go back to home and you can probably revoke the permissions. So takeaways would be HTML injection is enough. You don't actually require to fetch such sensitive data. When you give certain permissions to certain origins, it is not sure that you are trusting this website and giving this website certain permissions. And reviews are the weakest link. Yeah, thank you.
In your CST remediation, you say that browsers could just show the iframes origin to the user. I wonder if the parent website gets the permission first and then the iframe is constructed.
Yes.
This won't work.
Yes. So attacking. So my talk was not to target the permission policy, but focusing the origin which has been displayed. So if we talk about your website, and your website is loading certain some website within the iframe, and you have a specified permission policy in which you have defined that this should be accessed from this origin only should be accessed. In that particular scenario, I might not be able to exploit this vulnerability. And but if it is not there, for sure it will work.
So if you would go to browser settings to revoke this permission, will it be stored under the parent or the malicious side?
Under the parent, because you ultimately have granted permissions on the parent domain. So if you browse that attacker.com, it will again ask you the permission.
Maybe in the demo you were showing the iframe in the URL in the get parameter. So does it? I guess it also works in like other ways, the HTML injection, right? Or yeah, just it was not demonstrated.
Yeah,
okay.
It was just a demonstration, pure demonstration. Yeah. Okay, so that's it. I mean, you can, if you have any questions or if you want to connect, you can reach out to me on Twitter or LinkedIn. Or I have recently posted a blog about Bobsuit where I have linked the activation keys, so you can just go there and read about my research on Medium. Thank you. Thanks everyone.